Hello everyone, in this video we will talk about Airbus A320 fuel system. The A320 fuel system is very much like a conventional jet aircraft fuel system. It has fuel tanks located in the center fuselage area and the wings. The center tank is located in the fuselage, and the inner tanks and outer tanks are located in the wings. 2 fuel pumps are installed in the center tanks, and 2 fuel pumps are installed in each inner tanks. 2 electrical transfer valves are mounted in each wing to permit fuel transfer from outer tank. The transfer valves automatically open when the inner tank fuel drops to below 750 liters, thus enabling the fuel to drain from the outer to inner tanks. When open, the valves are latched open. They will automatically close at the next refueling operation. Each inner tank feeds its respective engine. The center tank also feeds the engines. In normal operation, each engine is supplied by 1 pump in the center tank or 2 pumps in its own side inner tank. All wing tank pumps remain on throughout the flight. They are fitted with pressure relief sequence valves, which ensure that, when all pumps are running, the center tank pumps will deliver fuel preferentially. 2 engine low-pressure valves are installed to cut off fuel to the engines. A crossfeed valve is fitted to connect or isolate the left and right sides. The fuel system also feeds the APU. The left inner tank fuel line supplies the APU. The required pressure is normally available from tank pumps. If fuel pumps are off, the APU fuel pump starts automatically. A low-pressure valve is fitted to cut off fuel to the APU. This diagram represents the basics of the fuel system. Let's talk about the circulation of the fuel. So first, our drop of fuel gets picked up by one of the electric pumps and gets pumped into the fuel pipe towards the engine. Next, our drop of fuel runs through a number of valves. Most importantly, there are so-called non-return valves. These have the function to make sure that the fuel only goes in one direction, regardless of what the aircraft is doing. So even if we are going in a steep climb, steep descent, steep turn, the fuel must always be able to run towards the engine and never return back into the fuel tank. So these valves ensure that the fuel flow keeps going in the right direction. After the valves, system have a lot of filters that filter out any contaminants, any little particles, anything that is not supposed to be in the fuel system. We want to make sure that the fuel that enters the engine is in a perfect condition. After the filters, the fuel enters another valve. Now, usually that valve would just put the fuel drop to the next stage towards the engine. But today, this is not the case. Instead, the valve diverts our fuel drop away from the fuel system into the IDG. Now, what does that mean? Well, the IDG is Integrated Drive Generator. The Integrated Drive Generator is part of the engine and produces electricity for the aircraft. This generator runs very hot. In order that, system runs the fuel into a fuel oil heat exchanger to cool down the IDG. So in our case, the fuel is actually not used to run the engine. It is used to cool down the generator. And once it has done its job to cool down the IDG, it actually returns back into the fuel tank. So, why is that? The fuel is now warm. And we want warm fuel in the fuel tanks because this prevents icing on the wings. If you have a long flights at high altitude, the fuel inside the wings gets very cold, and this can lead to what we call cold-soaked wings. So, when you then descend and you fly through clouds, the water particles that hit the wing and freeze on the surface of the wing. In order to prevent that, now we have warm fuel in the tanks that keeps the wing slightly warm. Once our fuel drop is back in the wing tank, it actually starts the entire journey again through fuel pump to valves, to filter, and to the valve again. But this time, the valve sends it towards the engine. But before it enters the engine, it has to go to the fuel metering unit. The fuel metering unit decides how much fuel is injected into the engine. It's plugged into a huge amount of systems on the aircraft. Fuel metering unit makes sure that the appropriate amount of fuel is injected into the engine. Finally, the fuel enters the engine and ready for combustion. Thanks for watching the video. If you find it helpful, please like the video and don't forget to subscribe to the channel. See you in the other videos. Goodbye.